Alright, so as you guys might have noticed already, I'm not here today. I got caught up in contact tracing and quarantine, so I'm going to be working from home until the 19th, I believe. Um, it won't change much about the way class works. You guys will still be watching the videos that I make. If you ever have any questions, please email me. We can set up a Zoom call, or I can hopefully answer your question in email, and we'll get your questions answered, and hopefully you guys will still be able to get your work done and understand everything. All right. So what we're talking about today is very similar to what you guys did yesterday. Sorry about the dog again. But today we're talking about naming covalent compounds. So yesterday was ionic compounds, today is covalent compounds. So we'll just go over again one more time how to tell the difference between them. In covalent bonds, the electrons are shared. So you can see here, both of these atoms have a claim on these electrons. They're in both of their orbitals. All right, and covalent bonds are typically between a nonmetal and a nonmetal. So usually, when we're talking about these covalent bonds today, everything's going to be over here on this right side of the periodic table in the nonmetal section. Okay. Ionic bonds are when the atom gives up an electron and no longer has any claim to it. So you can see here, the chlorine took away this electron from the sodium, and the sodium doesn't want it anymore at all, and the chlorine's going to keep it and hold on to it. All right, and these are usually between a metal and a nonmetal. So that would be something from this left side of the periodic table and one from the right combining together. All right, the main type of covalent compound that you guys need to worry about are what are called binary covalent compounds, and that's when there are only two different elements involved. All right, later on, we'll talk about naming some of the different types of organic compounds out there that are covalent bonds, but today all we're worried about is the binary ones. So when we're naming those, there's 4 rules when it comes down to it. So your first thing you're going to do is look at your formula, and whichever one of the two is the furthest to the left on the periodic table, that's the one that comes first. So you'll just find both of your elements on here, and whichever one is furthest to the left, that'll be the first one you say. All right. The other one, whichever the second element that you have is, you can do the same thing you did with the ionic ones and replace the end of it with IDE to make it an "ide" ending instead of however it ends normally. Alright, and then rule 3 is where it gets really different from the ionic ones. When we were talking about ionic compounds, we had the benefit of the charges to tell us how many of each atom there needed to be to balance it out. With covalent compounds, it's not that convenient, right? Covalent bonds can do all kinds of weird stuff with double bonds and triple bonds and all that junk. So it's not immediately obvious if I just said nitrogen and oxygen, how many of each would be bonded together. So in order to fix that, when you're calling something by its name, you use prefixes like mono, di, tri, and so on to show how many of each atom there's going to be in the formula. All right, and so the only real exception to that is if the first element that you're listing there's only one of. Instead of writing out mono carbon or mono whatever, if it's the first element in the formula, the mono is implied, so you don't have to write it. Right, so the prefixes that you guys should memorize, really they're pretty straightforward, with the exception of maybe tetra. It's pretty much just how you would think about like shapes in math, right? If you guys have taken geometry and you know the words for shapes with different numbers of sides, mono and di don't really make sense because you can't make a shape with only 1 or 2 sides. But for 1 and 2, it's mono and di. And then tri is triangle. So that's 3. Tetra, that's the one that's a little different. I honestly don't know why it's not quadra, like you'd think it would be, but what they use is tetra. So tetra stands for 4, and then penta is like pentagon. Pentagons have 5 sides, so if you've got 5 of something, you'll use the prefix penta. Hexa is for 6, hepta for 7, octo for 8, nona for 9, and deca for 10. You probably won't see anything above tetra that often. Mono through tetra are definitely the more common ones, but you should know what the rest of them are just in case they do pop up. All right, so we've got some examples. If we're given this formula with nitrogen and oxygen, and we go back and look at our rules, rule number 1 was to name the non-metal furthest to the left on the periodic table by its element name. So the one furthest to the left comes first. So if we've got nitrogen and oxygen, nitrogen's further left, so we're going to name it first. So we'd say nitrogen, and then the other one by its elemental name with an "ide" ending, so oxygen. So we've got nitrogen oxide is what we're looking at. Then we're going to use our prefixes to show how many of each there are. So let's go back to that problem. We've got 2 nitrogens here and 4 oxygens. So if we look at our prefixes, it should be, dinitrogen for the 2 of them, and then tetraoxide. So dinitrogen tetraoxide. All right, there's a weird thing that happens with oxygen since it starts with a vowel, the O, and it's pretty much the only one you're going to have to worry about this with. But when the prefix before oxygen is mono or tetra, or any of these ones that end in A or O, so mono, tetra, penta, hexa, hepta, octo, whatever, all these guys, you're going to leave out this A or the O there. So instead of tetraoxide, it just becomes tetroxide like we have here. Right? And it's not wrong if you do it the other way, if you write out tetraoxide, but this is kind of just a convention. I don't know why it is that way, but that's the way it is. All right, so number 2, we've got carbon and oxygen. Again, the one furthest to the left comes first. So carbon is further left than your oxygen. We're going to say carbon, oxide. We need to figure out how many of each there are. So 1 carbon. So it would be monocarbon. But the rule, number 4, says that if the first prefix would be mono, you don't have to write it. So instead of saying monocarbon here, we just say carbon. And then there's 2 oxygens, so that would be dioxide. So carbon dioxide. Easy peasy. This one we've got carbon and Cl, which is chlorine. So carbon's further left, so it comes first. And chlorine would turn into chloride, just like it would if it was an ion. And then we've got 1 carbon. And again, if it's the first one, you don't have to write the mono. So this would just be carbon. And then 4 chlorines would be tetra as our prefix. So this would look like carbon tetrachloride. Okay, we'll do a little bit of practice going the opposite way, and then I'll let y'all get to work on the homework. So if you're given the name and you need to work backwards and find the formula, oops, I forgot to change this. It still says ionic. Hold on. The counselor's calling me. Okay, so where were we? Right, when you're given the name of a compound and it wants you to find the formula, then you kind of just work backwards, right? It tells you dinitrogen, so you know that means you're going to have two nitrogens, and then monoxide. Mono is the prefix for one, so it's going to be one oxygen. So you would write it out as N2O, two nitrogens and one oxygen. Pretty simple stuff. Okay, the second one, arsenic trifluoride. You're going to go find arsenic on the periodic table. That's As. And then fluoride would be fluorine up here, F. So if there's no prefix for this first one, that means you for sure got just one of them. So you'd say As, and then trifluoride means you have three of the Fs. So it's AsF3. Same thing on this last one, dihydrogen monoxide. Excuse me. So dihydrogen, the di means you've got two of them. And then monoxide, mono means there's only one oxygen. So this would look like H2O. All right. If you guys have any questions about this, let me know. I'm available all day. So whenever you're working on it, if you have questions, just give me a call. All right. Good luck.